Welcome to the Chapter 14 of the Oil and Gas Engineering Guide audiobook. In this section, we will review the overall plant design work process among the various disciplines and how their work integrates. It all starts with the functional requirements from business, the feedstock and the required products. The process engineers perform process simulations and develop process schemes in order to transform the feedstock into the required products. Upon completion of these simulations, and once they have found the suitable process scheme, they issue the process flow diagrams and the heat and material balances. These documents form the basis for the plant functional description. The heat and mass balance allows to identify and specify the duty of each equipment. Process then performs the sizing of process equipment on the basis of the flow of fluids that are being handled in such equipment, the gas flow, the liquid flow. The process equipment sizing yields equipment dimensions, together with the process flow diagrams, which show which equipment is connected to which. It allows to establish the plant layout. Safety engineering comes in at this stage. They identify the hazardous materials and they prescribe some safety distance between hazardous equipment. The heat and mass balance allows to identify all types of fluids and their conditions in the various pieces of equipment and pipes of the plant. This, in turn, allows to select the proper materials of construction. Stainless steel will be selected for highly corrosive surfaces, whereas ordinary carbon steel will be selected when corrosion is not an issue. Once the material of construction of equipment has been specified, the equipment can be purchased from vendors and their mechanical design can be performed. This will result in equipment drawings showing precisely all information about the equipment, such as dimensions, positions of support, as well as weight and loads on foundation, position of piping connections, and so on. Such information will allow to comfort the plant layout. The finalization of the plant layout and information from equipment vendors, such as equipment dimensions and weights, allow to perform the design of the process structures, the equipment bearing structures, be they made of concrete or steel. The information from vendors also allows to design the equipment foundations. P&IDs are an essential document in the plant design, as they depict all the operational features such as valves, as well as lines and instruments that will be available for the operator to control, to monitor the process. and also for the operator to perform maintenance on equipment. Once the PNIDs are established, since they fix the various pipes, these pipes can be designed. The piping design entails the definition of a pipe routing that will meet a number of requirements, including accessibility for the operator to operate the valves and to have access to instrumentation on the pipes. It also involves calculations of lines subject to thermal expansion. Such calculations determine the requirement for expansion loops, and such expansion loops give rise to additional steel structures. Once piping calculations are completed and the required expansion loops are identified, the corresponding loads and geometry is given by piping to civil. Back to piping design. Once the calculations have been completed and a significant amount of pipes have been routed in the 3D model, the piping material takeoff can be extracted from the model. This will allow the first set of piping materials to be purchased. Before piping construction drawings, i.e. isometric drawings, can be issued, information is needed from equipment vendors about the precise position of equipment nozzles. The piping and instrumentation diagrams define precisely the instrumentation and control. Therefore, they are also the basis for the instrument and control engineer to specify and purchase the field instrumentation as well as the control system. The electrical design starts with the inventory of all the plant power consumers. This allows to size the power generation. The plant layout is used to define the architecture of the electrical distribution and the number of substations, among other things. Power cables are sized and their routes are defined, and since these cables are installed underground, such information is provided to the civil engineer, which performs the underground networks layout drawings. Quite a few networks are located underground, and the civil engineer coordinates their respective positions. The networks include the electrical and instrumentation cables, the underground piping services, such as the drains, the process drains, the pipe support foundations, the fire-water network designed by the safety engineer, as well as the plant rain-water drainage network. This ends this presentation of the overall plant design development. We have here a synoptic showing the interfaces between the various disciplines. Let's show these various disciplines. Process engineering is shown in blue color. Equipment engineering is shown in pink color, and this is not actually an engineering discipline, but these represents vendors of equipment. Plant layout is shown here. Safety engineering, instrumentation and automation. Piping is shown in green with its various components, calculations, design, and materials and material selection as well. Electrical engineering is shown here, and civil is shown in brown. Now that we have defined such synoptic, let's look at the critical steps, the critical stages in plant design. First of all, a plant is designed around equipment. In order to be able to design the plant, information from equipment vendors is necessary. Therefore, the equipment must be ordered at an early stage in order to have the equipment vendor information early to develop the plant design. So, the first critical path is that leading to ordering the process equipment. It goes through the process simulations and process sizing and preparation of the material requisition, technical bid tabulation, and equipment purchase. Once some information, at least preliminary information from equipment is available, it's possible to nail down the plant layout, which is another essential step for virtually all engineering disciplines to proceed with their work. This is done with the client during the first, also called 30%, plant model review, which is done in 3D. The most important document in a process plant are the piping and instrumentation diagrams. Freezing such diagrams at an early stage is required in order to allow piping design and instrumentation and control design to progress and proceed. Therefore, P&IDs must be reviewed between the engineer and the owner at an early stage. This is done during the P&ID review meeting, which is also an essential step in the development of the plant design. Once the piping instrumentation diagrams have been agreed between the engineer and the owner, the plant layout has been frozen, and the pipe design has progressed, it's possible to prepare the first list of required piping materials and to order the same. This is very critical, as piping is indeed what determines the duration of a project. It is on the critical path of the project. Once piping materials are ordered, the other thing that is required at site to progress with piping construction are the drawings. These drawings will require that the connections to equipment is finalized. This will require to have vendor drawings, finalized vendor drawings for equipment as well as inline instrumentation. Another priority of the design work that is often neglected is to focus on the underground networks. Indeed, underground networks are installed at site before any above-ground networks. Indeed, as you can see on the picture, the equipment, the cranes and so on to install equipment and pipes cannot access the area before the underground networks are installed and the area is backfilled. We have now come to the end of this presentation, and I hope you enjoyed this synoptic showing the interactions between the various engineering disciplines as well as the overall plant design sequence. Large projects are complex, and there are so many different activities and disciplines. One must be focused on the most important areas. Ordering equipment, finalizing the plant layout and the PNIDs, and attending to the critical path of the project with ordering of piping materials and issue of piping isometrics. That's all, folks. I hope this presentation will be useful to you. Any comments, questions, please drop me an email, herfbaron@gmail.com. Bye bye.